So this video we are looking at advanced variances, specifically material variances there, as we can see in the question. So we'll go straight into a question to get to even understand these variances. A marker company makes product Y by mixing together two ingredients A and B. The standard cost card for 1 unit of Y is as follows. Material A, B, as we can see there, with their standard kgs per unit, their standard costs per kg, and their standard costs per unit. The budgeted output for August was 60 units. After 1 month of production, 50 units of Y were produced from 110 kilograms of A and 25 kilograms of B. Calculate the material usage variance. How do we calculate material usage? So there's just a formula for that as well. Material usage is equal to standard quantity minus actual quantity, of course, times the standard price. And since these are in kilograms, we are going to multiply by a price per kg. Let's remember that. So let's do that. What is the standard quantity in our question? Let's get back. So standard quantity, most of the time to find standard quantity, we base it on actual results. That's how it is. You use actual results and then you go and convert them as per standard. So what are the actual production in that month? They've told us that it was 50 units. I don't know if you've seen that. So get to convert these 50 units and see how many kilograms they should have used instead of what they have shown in the actual result, and then they used 110 of A and 225 of B. Now I also want to see the standard of those 50 units, what it should have actually been. That's what standard is all about. So you get the 50 units and then take it to the proportions of A and B there under the kg per unit column and convert it to see how many kilograms they should have used. And this is what I'm going to do on the next page. So you've got product A and material A and B. Then now there was 2 and 5. Now you're trying to convert these 50 units to see how many kgs it should have used according to A. Here it's showing us that they should have used 100 for A, and here, if what about on B, they should have used 250 for B. So those are your standard quantities. As we said, standard gets the actual production, of course, in terms of their units there. Then you get to see how much should they actually have used based on those units that they produced. And then you're comparing standard with actual. That's a material usage variance. So we're going to do this. 100, 250. This is product A. Material A and B. That is your standard. You're comparing it with actual. Actual, what was the actual? They told us that 110 and 225. Get the variance. The variance is just the difference of standard and actual there. That's your variance first of all, which is here there is 10. Is this adverse or favorable? So you need to even be labeling these things. So standard is less than actual according to A, material A. What does that mean? Favorable or adverse? If standard is less than actual, then you have an adverse variance, okay, because these are costs. Like your actual result is more than what was actually planned, so it's not that much should have been, which is not a good thing. Then standard here is 250 for B and actual is 225. Well, this is a favorable variance. Why do I say that? Well, the standard is higher than the actual, meaning they worked well, so it becomes favorable. You found the variances. You're not done. Remember, it's times standard price. The variance is not done. So these are your variances, adverse and favorable. Then multiply them by the standard prices that were available. So for A, there was a standard price, but per what? Per kg. Please just be careful. Price per kg. So if you get back the question, there's that column which was price per kg. You'll find that for A, this was the price available for A, 1.5 kilograms per kg. This other one was 1.75 per kg. Then you find the answers. Okay, so when you start multiplying that, what are we getting as the material variance there? So for the first one, it's 15. Okay, of course, maintain the adverse sign because we're dealing with adverses of material A. Okay, then we got the next one, 25 by 1.75 43.75 favorable, and you get the total of the two. That's how you find the total material usage variance. So since it was in different materials, so you first treat them separately, then at the end of the day you just add them together. Now since one of them is adverse, one of them is favorable, these are two different figures, and realistically this one should even be negative. You saw the time when we are getting to subtract from the beginning of material A here, this was supposed to be negative. It's just that, as we said, in variance analysis, most of the time we do not like write negative, this adverse, no, but we know mathematically that this should have been negative. So it's like this negative has proceeded here, negative, and that's why I'm saying this figure is one which is negative. So when you're putting them together, it will be like negative 15 plus 43. So what's happening here? Then you find that the variance is 28.75. Done. That's how you find the material usage, which can be proven by the next two questions which they are asking us in the next question. The same question, sorry. So they've asked us material mix variance and calculate the material yield variance. So these two variances, they get to prove what we've just from finding the material usage. That's how it is. That's something to know. So we'll get back to that 28.75 and see that we are really correct or we are wrong. It will prove us wrong after we've dealt with these two. So let's find first material mix. How do you find material mix variance? Same details as we used last time, but I'll show you the formula first. Material mix variance, it's actual quantity in standard mix. So they say in the formula there, actual quantity in standard mix minus actual quantity times, of course, the standard price. And just abbreviate these shortly, standard price. So that's your formula, and that's what you're working with to find material mix variance. So what do they mean by actual quantity in standard mix? Actual quantity in standard mix goes like this. So what you do is that go to the cost card, your initial cost card up there, you'll find that initially under that kg per unit column, right, there were these figures 2 and 5. Okay, so what they mean by standard mix, this is your standard mix, what was initially there in the cost card before they gave you the actual results below, what they actually did. So what you're supposed to do is that make ratios out of these proportions according to the standard mix in the standard cost card there, using the kgs per unit. Those are the ones you're supposed to use, okay, because you're trying to find the standard for the kilograms that they are actually also showing there. That's why I'm using the kgs per unit figures here. So make ratios like you'd say the first one, this is for A, sorry, and this is for B. Meaning for A we'll be using 2 over 7, for B we'll be using 5 over 7. Now moving together there. Then what are you going to be multiplying this by? They said actual quantity in standard mix. So standard mix, you've now known it. Now what about actual quantity? What's the actual quantity? Actual quantity for A, we were told that it's 110. Actual quantity for B, 225. Therefore, get their total first, so that you can come and put those ratios very well. 335. That's their total actual usage in material. Yeah. So now you want to find now the actual, of course, the actual quantity, yes, which is 335 in the standard mix. So you're going to use this actual 335, but now proportioning it to the standard mix, like how it should be. So it will be like this 335 and multiply it first of all by 2 over 7. You'll find that it will give you what, 95, sorry, 95 point, say there are more decimals, but I'm rounding off to the first decimal, 95.7. Then do the same thing, try now 5. Remember, I have two ratios, but you're multiplying them where? On the total actual results. That's how you convert the actual quantity in standard mix. So you first find the actual quantity, 385. Then now you're making the actual quantity in the standard mix. So use the standard mix to multiply on that actual quantity and see how much it should have actually been based on the actual versus quantity. So you find the 5 over 7 here gives us 239.3. We are done. We have found the actual quantity in standard mix, these figures here. Then we get to compare with what? Actual results. That's what the formula says. So actual results, and we're going to compare them with the actual quantity in standard mix, which is what I've just circled in dots. Then you start finding the variances now. So we found this 95.7 for A, and for B we had found 239.3. The actual quantity there for A, 110, for B, 225. We're comparing these two according to the formula. The actual quantity in standard mix, which is this first part, minus actual quantity, which is the second part here. What's the variance? Get the differences there. You find the first one will give you 14.3. The other one, again 14.3. Okay, just so happened, favorable or adverse, actual quantity in standard mix. So the actual quantity in standard mix shows you a lower figure than the actual result itself, right? So this one would say adverse. Okay, why? Again, actual, the moment that you just see that an actual result is more in terms of material variances, that's adverse because they've overused. Here again, 235, what have they said here? Yeah, 239 from actual quantity standard mix, and then 225 is the actual. So here actual is lower than what the standard mix is showing us, so therefore this should be favorable here because actual is lower. So it's like you're putting these two figures together to find the variance. As I said, mathematically, if you subtract 95 minus 110, that's already a negative, so that we don't just show this, but in our minds we know that when we're coming to put this together, you just get to show them they are realistic cosines so you can get to do the correct math. So this is like negative 14.3 plus positive 14.3 giving us 0. Remember we found 0 like on the variances there when we found like, okay, the 14.3, which was first of all adverse, then the other one 14.3, which was favorable. Okay, which was like, okay, when we put this together, it's like it's 0 because one of them is negative and one is positive. But of course, times price. So let's just go ahead with the formula. Times price, standard price per kilogram. Okay, for A it's showing 1.5. For B, 1.75. The first answer here should give us what's 14.3 times 1.5? 21.45. So mind you, this figure is bearing a negative sign. As we said, we know that in our mind. We just don't usually represent it on our calculations there and on the paper, but we just know that, okay, when we're coming to put these figures together, one of them is negative and then one of them is of course positive depending on the sign there. So therefore we know that, okay, this 21.45, yes, it has the sign adverse because it's coming from an adverse symbol, but realistically it's a negative figure. Next, here below you find that here it's giving us 25.025. It's a favorable variance, and then this is positive, at least so as we saw initially where we got this figure. Initially it came out positive. When you put these together, it gives you 3.575. What sign we assign on this material mix? Well, I can just show you a trick. The larger of the two, it shows that favorable is larger than adverse. Therefore, this 3.575 will be assigned with the favorable sign. Okay. As it awaits the next variance material yield, so that when you put them together, they should go and prove usage, as you will see when we solve material yield. So just take note, your material mix variance is 3.575. Yield. How do you calculate material yield variance? Well, let me do the same thing. I show you the formula, then thereafter we get to as well calculate this material yield variance. So material yield variance, what's the formula? The formula is again actual quantity in standard mix. Okay, actual quantity in standard mix minus standard quantity. Okay, that's the formula for material yield variance, of course, times price as well, standard price. These are kgs as usual, so already we know which price we're going to pick. A price per kg, do not pick anything else. Okay, per kg, standard price per kg, that's the one I'm going to pick. So actual quantity in standard mix, we already have these figures at this point, right? We just calculated actual quantity in standard mix for A, give us 95.7. The next one, B, it's 23.239. Sorry, I beg your pardon on that one. Yeah, Then the other one, now the standard itself, that's what the formula also shows. Standard we calculated earlier on as 100. If you rewind the video, the time when we're looking at material usage, the first part, we found that it was 100 for A and 250 for B. Then get the differences to find the variance. Here it's, what's the difference on the first part? 4.3. Favorable, adverse. Standard is 100. Actual result in standard mix shows us 95.7. So here again, you are trying to see whether it's favorable or adverse, right? Okay, the standard is showing you that you should do this, okay? But you are slightly below, which is okay. When it comes to material, then if you're working below what they've planned, that's better. Then you're saving some material, you're not overusing. So this would be a favorable variance here. The next one, 239 and 250. Well, the difference first of all is 10.7. Favorable, adverse, same story as the first part A, because again standard showing us higher than what they've used, which is good in terms of material. Yeah, so favorable again. Then attach now a sign. You're now multiplying this by a price. So 4.3, okay, 10.7 times what price? We'll go to again your question. Which prices are you picking? Per kg prices. So for this one there was 1.5. Okay, and then this other one we had what's this, 1.75. and sorry, I'll take you back to material mix, in fact very soon. So because we're coming to compare those two figures, we have to compare those two. Yeah, so okay, first of all, this you have to do that. What answer are we getting? The first part, 4.3 times 1.5, 6.45. Of course it's still favorable. Then the next one, 10.7 times 1.75. This is 18.725. Since they're all favorable, we'll just go ahead and add. It's like they've got the same sign. They're all negative and negative. In short, if you really look at them mathematically as well. These two figures, when you add them, we're getting 25.175 as the material yield variance. Now, of course, favorable, by the way, yeah, favorable is a sign on it. Now we get to put these two figures, yield and mix, to prove what we found in A, the material usage, so that we know that okay, we are correct. Then we get to prove and find our answer. So remember this figure on the screen. Go to your material mix, which we got as 3.575. okay, then yield, and by the way, that one came out as favorable. This one also 25.175, favorable as well. Favorable as well. Therefore, when they're all the same sign, we just add them just like that, since they're the same, which gives us 28.75, which gets to prove the what? The usage variance we found in A. So when you put these two together, most of the time, or always, it does give you the material usage. That's something to know. So that's all about material variances. Just know their formulas, then you are set on this. He is talking about a company made a product called BAC. BAC had a standard direct material cost in the budget of 2.5 kilograms of material X at 4 kwacha per kg, which is 10 kwacha per kilogram. The average market price for material X during the period was 5 kwacha per kg, and it was decided to revise the material standard cost to allow for this. During the period, 8,000 units of BAC were manufactured. They required 22,000 kilograms of material X, which cost 123 kwacha. Required, calculate the material price planning variance. Okay, how do you calculate material price planning variance? Well, these two are calculated by, they've got their formula, so I'll share them one by one. Let's start with material price planning. Material planning, okay, material planning variance is equal to what? original plan or price minus your revised price, multiply these two which are in brackets by your actual quantity. Yeah, so original price or original budget minus revised budget, which are going to multiply by the actual quantity. So in our case, what is our actual quantity? They stated them about 22,000 kilograms that we are planning to that were actually done or produced in that period. What about the original price? So when you look at what's the paragraph there, the original price is what the company has already budgeted as self-starter, which is the 2.5 of material X at 4 kwacha 50. It's 4 kwacha per kg. So you're looking for that original budgeted price, which is 4 kwacha 15 way, which is 4 kwacha. I beg your pardon. It's actually 4 kwacha per kilogram. That's why we're picking that one. And we're picking per kilogram price there because those actual quantities that we're going to come and multiply at the end in kilograms. So the best is keep the prices in kilograms as well. So what about the revised price? How do you get it? Well, they've stated it in the paragraph. The revised market material standard costs during that period was 5. They've stated it somewhere there. So the average market price for material X is, for the period, was 5 kwacha, and it was decided to revise the standard cost. So that 5 kwacha is your revised. So you just go and put them in the formula and take note of the 22, which will be our actual quantity now as well. So you're going to first of all start with original. That's what the formula states there. The original budgeted price, which is 4 kwacha, minus the revised price, which is 5, multiplied by the actual quantity, which is 22. In this case, what do we get as the variance? 22,000. Adverse or favorable? Well, the original is 4, which is less than the revised. So when original is less than revised, this is an adverse. Why do we call this adverse? This variance is adverse because the original, or what has been budgeted, is at 4, but apparently the revised seems to be a higher price, and these are costs. So if what is they're actually revising is becoming more, that's becoming an adverse something variance. That's the interpretation that's there. Budgeted, if budgeted is less than what they are revising, just know that this is an adverse because you're going more than what you're planning in terms of cost, and that will be high for you as a company. So there. The other one is they asked for is material price operational variance. Material price operational variance. So for this one, it's the revised budgeted price minus the actual, the actual price. These two will be again multiplied by the actual quantity. So let's substitute. What is the revised price? 5 kwacha. This one we know from the previous part of the question. What about actual? Well, all we just know is that they are planning to have 22,000 kilograms, which cost how much? 123,000 kwacha. Now you're looking for a price per kilogram. How do we get it? Well, all we know is that we have this as the overall cost. What about the kilograms that they actually want to have done? 22,000. Since it's a price per kilogram, that's why we're dividing by kilograms. So when you divide these two figures, you get 5.59, which you can just round off to at least one decimal place, which will be like 5.6 as your actual quantity. Remember, actual, we have picked these two figures from actual because of that statement that was made here. Let me show you. So there's that statement that's saying during the period 8,000 units of back were manufactured. They required 22. Those same 8,000, they required 22,000 kilograms, which would cost them 123. So what they're telling you that to incur was incurred during a period. That's the actual. Okay, this is what actually happened, and that's how you know this is the actual they're talking about. And that's why I got to pick these figures, the 22 and the 123. But we're looking for a price per kilogram because the revised one is already in a price per kilogram. So we want to calculate things which are in the same unit formation. Huh? So therefore, you have, how do you get the price per kg? You have a cost there, okay? Then you're dividing it by kilograms because you want the price per kilogram. That's how you get it. And of course multiply by the actual quantity which they want to have produced, which is 22,000 kilograms because we are dealing in kilograms. So you found your 5.6, which is just going to say now 5, which is the revised, minus actual 5.6, close brackets multiplied by those actual quantity, which is in kilograms, giving you 13,200 adverse or favorable. Which one do you go for when your revised is less than actual? Is that favorable or what's this? Or would this be recognized as adverse? Which is 13,200. So this one will be adverse, by the way. Why am I calling this adverse? This is because look at the revised, it's 5. The actual 5.6. These are cost variances. That's something that should be understood. If an actual result here, you're comparing actual and what is being revised to try and adjust your cost card, but you've adjusted your cost card and you still find that the actual result is more, that becomes adverse because it will be an addition. It will be just too much of a cost. Huh? That's why usually to make this favorable, the actual was supposed to be lower. That shows that okay, it's just way, it's very much within your plans or your revised budget. Now the fact that it's higher, it's adverse. Therefore that's it.